Hello folks, let's have a look at the acids and base homework. So we're starting here with 12.2, write down the conjugate base of each of the following Bronsted-Lowry acids. And I want you to check off your homework against this and just make sure you're getting it right. If there's something you don't understand, just send me a quick message. So the first thing we've got to look at is we want to write down the conjugate base. I'm going to write down the conjugate base and we're given acids. So all of these are acids. So let's start with the first one, which is HCl. Now the rule here is when you want to turn an acid into a conjugate base, you donate a proton because an acid is a proton donor. So HCl has got to donate a proton. But when you donate a proton, remember that HCl is made up of two things. It is made up of H plus and Cl minus. They're the two constituents that we've got there. So if you're donating a proton, you're left with Cl minus. And this is where the confusion often occurs, because often students will see HCl, they donate the proton, and they literally just rub out the H and they're left with Cl, where it's not, it's Cl minus. So that's just something to bear in mind. On the next ones, show this out to make space. So again, on the next one, we've got H3O positive. So same thing here, if you remove a H plus, you're not just removing a H, it's a H plus. That's going to give you H2O because obviously you've lost a hydrogen, but also you're losing a plus. So this single plus that's here ends up becoming neutral. So if you're going from, you know, something like, let's say we have two negative, we have a single negative, we have neutral, and we have a single positive and a double positive. So if you are on single positive and you're losing a positive charge, you're back to neutral, which is no charge. The next one then you're going to look at is HSO4 negative. And again, same thing, if you're going to lose a H plus out of here, obviously the H is gone, so that gives you SO4, but you also got to lose that positive. Now again, you're already on -1. So what happens when you lose it? You go back to -2. So SO4 becomes a dinegative ion. So you have to take into account the charges. The next one then is H2PO4. And a single negative. So again, same thing, we're losing one hydrogen, so we're left with a HPO4, and then the negative goes to dinegative. The next one then is H2S. So we end up with HS negative, because it's neutral up here. That's neutral, so it goes to negative. And then we've got HSO3. That's negative as well. So we lose the H, SO3, and then it becomes dinegative because you're losing the positive charge. It becomes more negative. HClO2 is going to give you ClO2 single negative. And then finally HNO2 is going to give you NO2 single negative. So that covers the first one. So moving on to the next one. Write down the conjugate acid of each of the following. So working off this is the same thing. A base turns into conjugate acid by accepting a proton because a base is a proton acceptor. So if we're looking at CH3COOH, whoops, I'm getting ahead of myself there. All right, so CH3COO negative, you're going to basically add on a hydrogen. You want to add on a proton, and it joins on there. Now, when that happens, you end up with CH3COO, and it's H. So that's it there. The H, the plus and the negative, they combine to give you a neutral molecule. So H2PO4, single negative. That there, add the hydrogen on, H3, and that's PO4. The negative goes to neutral because you're adding on a positive charge. Then we have HPO4 dinegative. That's going to become H2. Again, you're adding on the proton, PO4. And when you add on a proton, you're adding on a positive charge. So it goes from 2 negative to single negative because you're getting more positive. Next one is HSO3 single negative. Same thing here, H2SO3, and then the single negative goes to neutral, H2O. So it's obviously H3O, but then you're adding on a H plus, remember, so that gives you the positive. You're going from neutral to a positive. Next, CN3NH negative. So add on your H, so we got CN3NH2, because we now have two of them, and the negative goes to neutral by adding on a positive. SO3 dinegative. So you add on a H. So where do you add on the H here? At the start. HSO3, the dinegative becomes single negative, and then finally NH2, single negative, gives you NH3, and the negative goes to neutral. So that's working from a base to a conjugate acid. That's accepting a proton. Okay, so let's have a look at the next question. Orthophosphoric acid, H3PO4, is a tribasic acid, and the equation for the first association of the acid in aqueous solution is this. So first of all, let's have a look at this. Tribasic. What does tribasic acid mean? Tribasic acid means that you have H3 just there. So we have to find an equation for the second association. So basically, all we're actually going to do here is actually look at what is produced at the end, which is H2PO4. And it wants you to do this equation again using H2PO4 negative. And it's in aqueous solution, so you react it with water. And it's asking you to come up with what happens at the end. So now you have to analyze, well, what's happening here, what's the acid and what's the base. So you can see in the first equation, we have H3O, but we started with H2O. So clearly what's happening is the hydrogen is moving from H3PO4. So this is your proton donor, which is your acid. So in this particular case here, this is also going to be the acid. So this is going to donate a proton that direction. So when the proton donates that direction, you end up with H and you end up with PO4. And the charge, so you're losing a positive charge, so this is becoming dinegative. It's becoming more negative because you're losing a positive charge. Plus H3O. And that is positive because, again, you're gaining a positive. So this is an acid. This is the base because it's accepting it. And that's when you're moving from left to right. If you're moving from right to left, and remember, this symbol which we haven't studied yet is what's called equilibrium, which basically means it can move from left to right, and it can move from right to left as well. So moving from right to left this time, so we're going to end up at H2O on the left hand side. So obviously this here is donating a H plus, because if the H3O donates a H plus, when it moves over to the left hand side, it ends up becoming H2O. So because of that, this is an acid and this is a base. And then it asks you to indicate, of course, the acid. It says the conjugate pair is present in the second association. So this here is the second association. So to work that out, all you've got to do is take your acid on this side here and your base on this side. That is your conjugate acid base pair, and you would write that down. So it's H2PO4 negative and HPO4 dinegative is conjugate acid base pair. Same thing applies then for the other two. You can also say that H2O and H3O positive is also a conjugate acid base pair. And one of the rules for for conjugate acid-base pairs is they should differ by a proton. So always go back to your question and say, is the difference between these two a proton? And is the difference between these two a proton? As in, when I say a proton, I mean H plus. So is it the H and is it the plus the difference? And it is, so this makes sense. Either one of these will do, and it doesn't matter whether the acid or the base is first or second. Okay, moving on to 12.6. Write down the following equations and indicate in each case the acids, the bases, and the conjugate acid-base pairs present. So we'll try one or two of these. We won't go through all of them. They should be straightforward then. So plus H2O gives you NH4 plus OH minus. So on this one here, the H2O is turning into OH minus. So this must lose a hydrogen at some point. So if it's losing the hydrogen, it can only lose it to NH3. So if it's donating it, that means this is the acid. And if this is receiving it, this is the base. These are all equilibrium, so you got to look at it from both sides. So there's an acid and a base. And on this side, if you're starting here, this one here, OH minus and NH4, well then the hydrogen is obviously moving from here to here because OH minus ends up at H2O. So this here is donating the H plus. So this would be the acid in this case. This would be the base. And once you have that down, then you can put in your acid-base pair. So you've got NH3 and you have NH4 positive is your conjugate acid-base pair. Now that's one of them. The other one, of course, is H2O and OH minus. It's another conjugate acid-base pair. And that's all there is for that. The rest of them, again, should be all straightforward. And maybe we'll take one more at the end. So we've got HSO4 negative plus OH minus, equilibrium SO4 dinegative plus H2O. So same thing here. So look at this. Right, so HSO4 and it ends up at SO4 dinegative on the other side. So this obviously is going to donate. So that makes this the acid. It makes this the base because it's accepting. And then working backwards, H2O and SO4. Well, H2O ends up becoming OH minus. So this is the movement of the hydrogen. So this is an acid and this is a base for accepting it. And then our acid-base pair, and this is the way you need to write it down in your leaving cert. If it asks you for a conjugate acid-base pair, it's HSO4 negative. You have to put down both of them, and SO4 dinegative. So that's one acid-base pair. And then finally the other one then is OH minus and H2O. And again, just check that they differ by a proton. Okay, so I hope that was helpful. There should be another video now coming in the next day or two on our next section. Okay, thank you.